Hello everybody. So today I'd like to talk about a pretty interesting twist on the research of one of my colleagues from Germany, Dr. Thomas von Vodke. And I and many of the plasma researchers have often identified peroxynitrate or peroxynitrous acid as one of the key ingredients in allowing us to achieve great antimicrobial efficiency in plasma treatments. And we've always talked about just synthesizing peroxynitrous acid in a solution. And here the team did it. So let's take a look at this paper. It was published very recently, 19th of August 2021, in the journal called Antibiotics. So very interesting place to publish this work. The authors identified that peroxynitrite and peroxynitrous acid are well-known, short-acting reactive species with natural oxidative properties, and they're well-known for their antimicrobial abilities, but they haven't yet been used in practical applications. So this paper attempts to make a first step into that direction. Many of you aren't subscribed. Only around 10% of my subscribed viewers come to this channel, so please don't forget to click the subscribe and click the little bell icon. I greatly appreciate your support, and as always, please leave all the comments and thoughts and ideas that you may have. I read all of the comments and I follow your advice, and my next review will be based on the request made by one of you guys. So happy viewing, and let's talk about this paper. And if you want just the summary, if that's all you came here for, well, if you mix acidified hydrogen peroxide and sodium nitrate, you will get peroxynitrous acid, and it's an excellent antimicrobial, and it looks like, at least initially, there are few, if any, mutagenic properties. The devil, of course, is in the details, so let's talk about this, and at the very end, there's an interesting question of what does it mean for a company to have two CEOs. But anyway, so let's dive right into this. From literature, we have that this peroxynitrous acid is known for its strong antimicrobial properties, and it's also associated with DNA, lipid, and protein damage. So while it may be a great disinfectant, it might also have some potential mutagenic effects. And the authors are proposing to use this solution as a hand washing technique. Interesting. So definitely we should look at mutagenicity. Peroxynitrous acid was shown as a disinfectant by itself, or its byproducts like OH radical here is also known for its great antimicrobial properties. The lifetime of this thing, however, is pretty low. So we're looking at just under a second in normal room conditions, and milliseconds if it's in physiological media. Here they say due to presence of CO2, but it's CO2, organic load, and all other things that can be oxidized using this molecule. So the big problem is, how do you use something that has a very short lifetime? And authors address this by mixing hydrogen peroxide with sodium nitrate, waiting for 30 seconds, and then mixing it with bacteria. So let's look at some details. There are many graphs here, very important details, but I'll brush over them because I don't think they contribute to the big picture. The main point for me here is the concentration of peroxynitrous acid at pH 2 rapidly increases right after you mixed everything, and then within a minute drops 3 times. So you have to use this thing very quickly. It's an engineering trick of how do you make something that's highly reactive, use it right away, but it disappears, which is good. So there are no harmful or majorly harmful byproducts. And authors also mention that little is known about mutagenic properties of peroxynitrous acid, so they attempt to make the first steps towards investigating it. The authors also introduce this W factor, and they correlate it with bacterial inactivation. So basically, if this W is more than 1, we get 99.99% or 4 log kill. Great! For the microorganism, they're working with E. coli DSM 11250. It's just a type of E. coli. There are very, very, very many kinds of E. coli. I usually work with E. coli 0157H7 because it was linked to many foodborne infections. The authors are more interested in hand washing, so this is the organism they have selected. And they're working with 8 times 10 to 10 colony forming units per milliliter. So basically 1 with 8 zeros of these E. coli per milliliter of solution. So that's pretty high concentration. For Ames test, they use a different kind of E. coli, which is typically used for testing mutagenicity of solution. In both cases, they're working with liquid solution. So they're not putting this peroxynitrous acid on skin, they're mixing fluid E. coli with fluid disinfectant. But it's good for an initial study. And the authors, in the perfect style for most of German researchers, they go into great detail looking at concentrations ranging from 0.05 millimolar all the way up to 30 millimolar, looking at the broad spectrum of possibilities. The important time parameters is they mix, they wait 30 seconds, and then they mix the peroxynitrous acid with E. coli, and then they wait 15 to 20 seconds and plate. So the reaction time given is an order of 20 seconds. Negative control is something to mimic no treatment at all. They follow the same exact procedures, but they use distilled water. Well, that's great. Reduction factor is difference between the logs. So they compare how many bacteria are in the control on logarithmic scale minus how many bacteria in the treatment. So if they started with 8 times 10 to 10 and they arrived to 8 times 10 to 4, well, that constitutes to a 4 log reduction. Of course, they study wide range of pH values because the authors show that pH is pretty important in these experiments. The authors also devised this evaluation of efficacy parameter, which I find to be a little bit too complicated. I don't fully understand the reason for deriving this number. Basically, it's looking at how many E. coli this solution can kill. So let's look at that. And for the Ames test, for the mutagenicity test, they employ ultra-pure water as control, as no treatment. Their positive control is this unpronounceable chemical, 4-nitroqualanine N-oxide. It is a known mutagenic agent. So they compare mutagenicity of this compound with mutagenicity of peroxynitrous acid. And they do it with this E. coli WP2 strand. So let's look at the results. In my opinion, this graph is the most important graph in this paper, and it's the only graph in this paper that I will remember over the long period of time. So we're looking at pH range from 2 to 6 and concentration, initial concentration of hydrogen peroxide and sodium nitrate in the range from 0 millimolar to 30 millimolar. And we have this area where we're achieving over 4 log reductions, so greater than 99.99% reduction in E. coli. And this range is quite broad, pH 2.5 to 4, and initial concentrations in a range of maybe 7 millimolar all the way up to 30. So this is a broad range where this mixture is highly effective against E. coli. Another point that authors bring up is when you're talking about disinfection of hands, for example, you have high organic load. Hands are organic, they have some oils on them. So these experiments are performed in the solution containing queso broth. It's an organic broth mimicking presence of very high organic load, like organic oils or other dirt that we might have in our hands. All of this high level inactivation that we've observed is in the presence of this broth, which is very promising if you ask me. It's funny that the authors mentioned that previous publications that investigated antimicrobial efficacy of plasma activated water indicate that peroxynitrous acid is the most important reactive species for the elimination of bacteria. Absolutely. When I started my career over 20 years ago in plasma, it was widely believed that nitric oxide is one of the major reactive species generated in plasma for disinfection. My own PhD work showed that not only also effective reactive oxygen species like O2-, OH radical, hydrogen peroxide, and presence of ions is most important, and beyond my thesis, many other groups, including our group, have demonstrated that in fact peroxynitrous acid or peroxinitrite are the major reactive species generated in plasma responsible for effective inactivation. So here again the authors rely on their wisdom obtained from plasma and generate this reactive species all by itself without the complexity of having to use electric discharges. Beautiful. So we can make plasma from off-the-shelf chemicals. Excellent. Excellent work, guys. So we'll come back to this table in a bit. For some reason they put the table here and a text talking about it all the way on the bottom. But anyway, so Ames test, mutagenicity. At this point we know that this thing is excellent at inactivation of bacteria, but is it mutagenic to my hands? So for this, they tried to analyze this. The authors performed something called Ames test. They compare mutagenicity of 25 millimolar peroxide mixed with 25 millimolar NO2- with this fancy chemical that is a known mutagenic agent. However, this 25 millimolar is pretty high concentration. We already know that it kills pretty effectively, so they actually need to dilute it so that they're able to grow some bacteria while analyzing the mutagenic effect of this disinfectant. So it's a pretty tricky test, and the results can be somewhat inconclusive, and the authors are pretty transparent about that. If we look at the data, here is the fancy mutagenic chemical, and here is peroxynitrous acid. So we're looking at sample 1, sample 2, sample 3. So they analyzed it 3 times with concentration range from 100% of fancy chemical to 0.3%, and the same 100% of 25 plus 25 down to 0.4% of 25 plus 25. We see that 100% mixture looks like kills everything. There are no mutations, so we will see a number here that corresponds to a mutating E. coli. But they're all zeros, which is great, right? But the solution killed all of the E. coli. Same here. All zeros. Now we see at 10% of 25 plus 25. At 10% we see 7, 9, 11. So there are some mutations. However, I don't know why they didn't put control on the table. The negative control with ultra pure water results in 7 plus minus 1.2 CFU per plate. So our negative control, our treatment comprising of no treatment, just ultra pure water, results in about 7 CFU per plate of these mutated bacteria. So our baseline is around 7, and we get to the baseline around 10%, and here is 11 plus minus 9.7 plus minus 12. So looks like there is some kind of low level of mutation, but not as much. But comparing to a known mutagenic agent, we see these numbers are much higher. So peroxynitrous acid is definitely less mutagenic than the known mutagenic agent. However, to me at least, these results aren't very conclusive, because the 0.4% of 25 millimolar plus 25 millimolar is already getting close to micromolar, and micromolar isn't on this scale. It sort of is down to 0 where you have no inactivation. So we'd be interested more in this zone, but this zone kills everything, so it's hard to analyze mutagenicity. And authors rightly point out that this needs to be repeated with mammalian cells. And authors do mention that no clear result can be concluded on the mutagenic potential of the test product in this case. Why'd you do the test then? But it is a complicated test, and it has some positive indication that there may be low or no mutagenic effect. And we have solution, fluid solution, that kills everything really nicely. And authors, of course, say further testing is necessary to assess the mutagenic potential of peroxynitrous acid at higher concentrations. Very inconclusive findings in this paper, but very promising. So here we've come to the end of our discussion, but there are a couple of things I wanted to point out that I found interesting, or the questions that I have. First of all, conflict of interest. Two of the authors are shareholders and CEOs of Nebula Biosciences. CEOs? That's interesting. I'm just curious, so I googled this Nebula. Conveniently, the Google is open right here. This Nebula Biocides, interesting company. They looks like they're making a hand disinfection system. So this is a stand where you will come, I guess in a grocery store, and just put your hands in there for disinfection. Interesting. I wonder what it would look like. Very curious to see how this functions. But the website is absolutely beautiful, and we see people disinfecting hands right here. You can watch this video if you like. I will leave the website in the link down below, along with, of course, links to the paper and the journal rating and all of that. They're also thinking about selling this double solution. So this looks like a typical hospital bottle that has two sprayers. Where you push this, both of them will be pushed out. Nice. It's a bactericide, virucide, sporicide. I didn't see this data in the current paper, but I'm sure the data is forthcoming. Lo and behold, founder and CEO. Maybe somebody in the comments can explain to me how a company is able to have two chief executive officers. I'm very curious. Two is too many chefs in the kitchen. Two is too many bosses. Two is, well, I'm just curious what you guys think. And, finally, I looked at this sodium nitrite. It's a pretty nasty chemical. It's in its pure form, it's flammable, poisonous, dangerous to the environment, toxic, it's an oxidizer. It has a lot of problems. It's deadly to pigs. It's linked to carcinogenicity. So there's some issues I see. The bottom line, getting back to the paper, I think this is brilliant work, synthesizing a chemical that is claimed to be one of the major disinfectant in plasma treated water. They synthesize this chemical in a much purer form, and they show that it does in fact offer excellent disinfection. Engineering challenges await us. How do we work with a chemical that exists for seconds up to minutes? And I'm sure one of us will find and commercialize this solution. I wish Nebula Biocides all the luck, as this seems to be an excellent disinfection technology. Thank you for watching. Like, subscribe, leave a comment. See you guys in the next one. Take care.